Welcome to the video presentation of the Venus Exploration Project. In this video, we'll walk you through how we designed our robot and how the robot works in finding the rock samples and returning it to the lab. The following are pictures of our robot. There are two subsystems in the search sample system. The first one is the random searching system indicated in blue. In this system, the robot will randomly search for a rock sample. When the robot detects a sample, it will transition to the next subsystem, which is the grab sample subsystem, indicated in blue. Here it will grab the sample. When the sample is grabbed, it will transition to the Go Lab subsystem, indicated in yellow. Here the robot will go search for the lab. When the ramp of the lab is detected, it will transition to the drop sample in the lab subsystem, also indicated in yellow. It will drop the sample in the lab and reposition itself to continue its exploration. The whole system is a loop of these four subsystems. If the sample is lost while searching for the lab, it will restart the loop from the beginning as indicated by the arrow from the Go to Lab subsystem. The picture shown is our test layout for the project. This is the random searching subsystem. It consists of the following functions, which are avoiding the hills, avoiding the craters and borders, avoiding the lab, and detecting the sample. We will start with the avoiding hills function. It uses the ultrasound sensor and the servo, and it also uses the wheel servos. As you can see from the video, the robot detects the hill and then stops to change its trajectory. Then we have the avoiding borders and crater function. It uses the downward facing infrared sensors and the wheel servos. As you can see from the video and robot, it detects the borders and craters and it starts implementing the avoidance system. Then we have the avoiding lab function. It uses the downward-facing infrared sensors and the wheel servos. As you can see from the video, the robot detects the green borders and it starts implementing the avoiding system. Lastly, we have the sample detecting function. It uses the forward-facing infrared sensors, and as shown in the video, the robot detects the sample. Then we move on to the grab sample subsystem. It consists only of one function, which is the grab sample function. It uses the front and gripper infrared sensor. It also uses the wheel and gripper servos. As you can see from the video, the robot moves to the sample, grabs it, and continues to move on. Thirdly, we have the Go to Lab subsystem. It consists of the following functions, which are the avoiding the hills, avoiding the craters and borders, and finding the ramp. We will start off with the avoiding hill function. It uses the ultrasound sensor and servo, and it also uses the wheel servos. As you can see from the video, the robot detects the hill and then stops to change its trajectory. Then we have the avoiding borders and craters function. It uses the downward-facing infrared sensors and the wheel servos. And as seen from the video, the robot detects the borders and craters and it starts implementing the avoidance system. Lastly, we have finding the ramp function. It uses the downward-facing infrared sensors and the wheel servos. As seen from the video, the robot detects the green line and stops to readjust itself to be perpendicular to the line. Finally, we have the drop sample in the lab subsystem. It consists of the following functions, which are the driving up and down the ramp, drop the sample, and avoid collision on the ramp. Starting with the driving up and down function, it uses the downward-facing infrared sensor and the wheel servos. As seen from the video, it moves up the ramp and stops at the green line to start and following the function, which is dropping the sample. The drop sample function uses the gripper infrared and the gripper servos. As shown in the video, the robot drops the sample in the lab and then moves backwards to leave the ramp and continue finding other samples. Lastly, we have the avoid collision on the ramp function. It uses its Zigbee to avoid colliding with the second robot. As you can see from the following video presentation, all the systems of the robot work in tandem together. The robot first tries to collect the sample. After it collects it, it keeps searching for the ramp, and after it searches for the ramp, it moves up the ramp, drops the sample, and it goes back to start the whole system all over again.